So now we want to add a DynamoDB table to our whole serverless stocks to really make our app fully serverless. So let's go back to the code we had from before. And so as you can see, we have DynamoDB already in it. So this sounds about right. So let's go ahead and basically copy this code right here. And we're going to load the function. And here we create our Boto3 clients. So something you notice is that we create the client outside of the handler. So this is, again, if you remember, one of the best practice is to put the clients outside of your handler. It's very, very important. Here we load the table name. And the other thing we want to do is set this Boto3 client to be in the region name we are in. So here I will say region name equals os.environment. So we get another environment variable. And this time it's going to be called region name. And here I will say region name equals region name. So basically we set our DynamoDB client to be equal to the region in which we deploy our function. As we can see now, we are referencing two environment variables, region name and table name. And so we have to set them in the template.yaml. So how do we do this? Let's have a look at how it was done in the examples file. So this is our Lambda function. We don't need this anymore. And here is our template.yaml. And so now we have to reference DynamoDB. And so as you can see in the bottom, there is a table that gets created for us. And this table of type simple table. So let's go ahead and copy this. So we'll copy this simple table right here. Okay, table, and the type is of simple table. But I want to set a few properties because I don't want this table to cost you a lot of money. And so if we type simple table serverless options, that should be it. Here we go to simple table and we get the resource type. And so we get the different parameters we can use. One of them being, if we scroll down, the provision throughput. I want the provision throughput to be equal to 1 and 1, just so we have limited provision throughput and we don't overpay. We can also set a primary key. And so we can just copy this as well. So we get a full simple table that's going to be working. So let's copy these things. We have the primary key and we have the provision throughput. The primary key is going to be called greeting, and it's going to be a string. So we just have a partition key. And for the provision throughput, I said, well, let's use 2 and 2. So here is our simple table. And so now we need to set environment variables for our Lambda handler. For this, pretty easy. Again, let's go back and see how it was done. We use something called environment. And in there, we can reference the variables we want. So let's just go to environment. And we're going to set it right here, environment. And I'll have to indent it. Okay, the variables. The first one is going to be table name. And I'm going to do a reference function. So ref, like an interesting CloudFormation function, to the table that was created from before, the simple table. So here we have the table name that's set correctly. And the other environment variable that I set is the region name. And for this, I'll set a reference to AWS region, which is a pseudo parameter. If you remember it, this is a pseudo parameter that is provided directly by the AWS CloudFormation templates. Okay, so now we have our table name and our region name, and we have created a table. But if you remember, when we do this, we need to give ourselves, the Lambda function, the access to this simple table. For this, pretty easy. Again, we go ahead and we need to add policies. And these policies are going to be IAM policies we can add on to our Lambda function. So let's go and write policies right here. And the policy we want to add is DynamoDB CRUD policy. And the table name we reference has to be for the table name that was created. So ref table. And this will basically give us, okay, a DynamoDB policy that allows us to do CRUD operation on the table that was created. And so we get the full IAM policy. Now, in terms of what our application does, well, maybe we don't want to return hello world. Maybe we want to do something a little bit more interesting here. So we can use a scan operation. So DynamoDB, so dynamo dot scan, and then we have to reference a table name parameter. So table name equals, and we have to pass in the table name that we have retrieved from before. So table name equals table name. This is our scan result that is equals to this. And this is what we're going to pass. We're going to respond with the scan result. So a pretty simple function. We're just going to scan the table that was created. So that's it for our function. It just scans, our table that is created from this simple table thing. So now let's go ahead and deploy our function. So I'll just run these two things right here in my terminal. And so now we are in CloudFormation, the update is complete. And if you look at the resources being created, we now have a DynamoDB table that was being created. So we have a table in DynamoDB. Let's go into DynamoDB to see how things are. So DynamoDB, here we go. We go to tables, and here is my Hello World SAM table, who has a partition key named greeting, and it has 2 read capacity units and 2 write capacity units. Let's add a few items. So let's just create an item. I'll say greeting hello, and then click on save. This is our first greeting. And maybe I'll create another greeting called bonjour. This is in my language, French. So we have greeting and bonjour, but you can have other greetings if you wanted to. So we have 2 elements in our DynamoDB table, which is pretty cool. And now what we want to do is make sure that our function works properly. So let's go to our Lambda function. We'll refresh this page. And now if we scroll down and look at the environment variables, we can see that the region name was automatically set to EUS3, and our table name was automatically set to the table name that was created by DynamoDB. So our environment variables are correctly set. And so our code should be able to reference them. And it turns out that our code has not been updated for some reason. Let's have a look. Nope, the code wasn't updated because I probably forgot to save the code. So let's run this again. Okay, so my code is now updated, which is great. By the way, if we scroll down and look at the IAM role, it has created a Hello World SAM Hello World IAM role. So we could go to IAM to see what was done in there. So let's go to IAM, click on that role, and here is the role that was created by Hello World SAM. And it turns out it has a Lambda basic execution role, which is great, and also an inline policy allowing it to do DynamoDB get item, delete item, put item, scan, etc., all on my Hello World SAM table. So this is pretty awesome. So SAM framework just generated for us the DynamoDB, the API gateway, the Lambda function, the IAM roles, everything is perfect. So now, hopefully, if I go to my resources, to the get route and test it out, I'll click on test and click on test again. I get a 200, so it worked. And now it returns the response body, greeting, hello, greeting, bonjour. So everything I add into my DynamoDB will just be returned by the API gateway. And so overall, that seems like a lot of things we did, but we just put together the API gateway, the Lambda functions, the DynamoDB tables, the IAM policy all together, such as now I have an API that I can call straight from prod, for example. And if I go to this URL, prod/hello, it will return to me all the greetings that are in my DynamoDB table. And you could play and add more greetings here or remove them if you want. So that's it for this lecture on DynamoDB table. I hope you liked it, and I will see you in the next one.